Welcome back everyone to another episode of the Doom series, and in this video we are going to learn how to optimize our wall texturing by merging all our textures into a texture array. Alright, so up till now we have been doing texturing in a way in which we have got all the textures as uniforms, and we loop over all of our wall nodes and we do the textures that way. But we are going to change this and instead use texture arrays for the wall textures as well. Now the main problem, if I will actually go ahead and open up like our flat.texture.h file, you can see in here we have got this generate flat texture function, and what this does is that it just generates a single texture array with a bunch of textures. And the reason this is so easy is because all flats are the same size. However, all wall textures are actually not the same size, they may be different sizes. So what is the solution to this problem? Well, there can be multiple solutions, but the easiest and the best way that I have found is to just get the maximum texture size, so we can get the maximum size of the texture, and then we can create a texture array with each texture being of that size, because in a texture array in OpenGL all textures must be of the same size. So we can just do that. We can have a texture array, and that can contain as much space as it is needed for the largest texture, and then for the textures that we do not want, we can just leave that space unused. However, we'll also need to store the actual maximum texture coordinates, because they won't be in the 0 to 1 range, and then we need to add some clever mechanisms for having repeating textures working in the shader. So we'll look into all of that. So first of all, let's open up wall_texture.h. Now in here we have got a new function here which is called generate wall texture. It takes an array of wall textures, not called flat, just call it textures, and also a number of flats, which is something that you might expect, but it also takes an extra argument. Let me close this. So it also takes an extra argument, which is an array in which we will store the maximum coordinates of each textures, and this array is assumed to be already allocated memory of which has got vector2. It's a vector2 array with the number of flats, so actually number textures, so as many textures as there are, so it contains all of those. So we can just use this inside of our function for basically setting all of the maximum coordinates, which we can then use when we actually need them. So now let's go under wall_texture.c. In here we generate the texture. First of all, we set a maximum size which is 0 and a minimum size which is just set to infinity by default, and then we loop over this and set the maximum and minimum size depending on what the texture width or height is. Pretty basic stuff. Then we generate the texture, and this code is exactly the same as it was with flat texture. But the only thing that changes is that when setting the GL text storage 3D, we use the maximum size.x and y for this value, and we of course use the number of textures for the z value, and then we loop over each of the textures, and we basically set our maximum coordinates, the ith value of the maximum coordinates, which means for the current texture we get the texture width and just divide it by the max size. For example, if the texture is 64 by 64, well, the max size is say 128 by 256, then in that case it will end up as 0.5 and 0.25. So that will be the maximum coordinates, and this will be very useful. And then we can just use GL text sub image 3D for setting a part of the texture. So we are going to, for the x and y offset, that's going to be 0 because the texture is going to be located at the top left. For the z offset, we are going to have it be I. This first argument, by the way, is the LOD, which is 0. We have done this stuff before in the flat texture. Then we set the texture width and height of the actual texture, and just the other space we just leave it blank. And then we use 1 for the z value because we are not actually going over multiple z values. Then we use GL read integer as a type and GL unsigned byte as actual data type, and we just pass the textures data. So that should basically create a texture array with all of the textures that we need. Now how are we going to go about using this? So for that, let's go ahead and let's look in our engine. Actually, let's look in our renderer code. So in renderer, I have changed that we've got two functions here. One is for setting the wall texture array, and the other is for setting the flat texture array. So let me open up render.c and let's see how this stuff works. So in here you can see we have got a new vertex attribute. So this is represents the max texture coordinates. We will need this inside of the actual shader because we will need this to implement proper repeating of texture, as some places might appear black, so we need to kind of make sure we repeat the texture properly, and for that we do require our maximum texture coordinates. And since we are having this here inside of mesh.h, we have also got a vector 2 here in the end called maximum chords, and in mesh.c we just assign that in the vertex attribute like this. For the flats and other stuff, we just leave this field empty. Alright, so that's pretty basic stuff, and here we have got a out variable as well. However, this also must be flat out, and the reason we use flat out is because otherwise OpenGL will apply interpolation to this. So in order to make sure that OpenGL does not apply interpolation but passes the maximum texture coordinates as is, we are going to do it this way. Otherwise OpenGL will apply interpolation and the stuff won't really look that much right. Anyway, we set the out value to the max texture coordinates that we have got, and here we just have a flat in vec2 max texture coordinates, and here I have changed the uniforms here. Now both of these are used sampler to the arrays, and one is the flat texture while the other is the wall texture. And in here you can see that we use the flat texture if the texture type is 1. However, if the texture type is 2, then we use the wall texture, and we go ahead and say inside of the actual value here is a bit complicated stuff because we need this in order to make sure that the texture tiling and repeating works correctly. So we first divide our texture coordinates by our maximum texture coordinates. So let us, for example, say that we are drawing the last point of the vertex, which is at texture coordinates 0.6 and 0.6. Now the whole texture of course is 1, but the actual texture that we are using, because it's based on the maximum size, so the texture we are using, let's say it has got only 0.5 by 0.5 as the maximum texture coordinates. So if you've got 0.6, we want to repeat, and with default behavior it will just display the black region, the empty texture. So in order to fix this, what we do is we take our texture coordinates, which are for example 0.6 by 0.6, divide by maximum texture coordinates, which gives us 1.2, and then we use the fract function, which basically gives the fractional part of a floating point number, essentially subtracts the floor of this value from this. So for example, if you've got like 1.2, we will get 0.2, which is the correct behavior for repeating. But then we have got our texture coordinates in the 0 to 1 range. So in order to convert this into the actual range of the whole texture, we need to multiply this again by the maximum texture coordinates, and for the z value we just pass the texture index here, and yeah, that's some pretty basic stuff. And of course the other thing we change is that we've got these functions here setting the wall texture and everything, and inside of initiator we now use the correct names for the uniforms. Apart from that, nothing really changes. So let's go ahead and open up engine.c, and in here let's actually look at some stuff which actually like how this actually works. So here you can see instead of having a array of actual GLU ints, now we have got a single GLU int called the wall texture array, but we have also got an array of vector 2s called wall max coordinates. And what we do is when we are creating our textures, we create the textures, we initialize the wall texture information, we set the maximum chords and we allocate memory for that, and then we loop over all the texture, we set the info here correctly, and then we set our wall texture array by using the generate wall texture array function, and we pass it all of the appropriate parameters, and in the end we free the textures. So yeah, that's some pretty basic stuff. So now let's go down into our other engine render function, and in here we don't actually have that custom texture setting stuff, but instead we just set the flat texture array to this and set the wall texture to the wall texture array, and then we just use it. So we don't have to actually set everything for each mesh that we are drawing. So that's all pretty cool. And the next thing that we are going to look into is that inside of generate meshes, you will see now the major difference here. So inside of where we are handling our walls, basically for all of the walls we have got this done in a similar way. So I'll just show you for the basic walls. So what we do is we set the get the correct maximum coordinates where to the side depth texture. It will be middle for the normal walls, and for portal walls it might be upper or lower depending on which side, and we get the maximum coordinates, and then with our texture x0 and texture y and all basically the texture coordinates that we have calculated, we multiply them by these maximum coordinates to get them into the actual correct range. Then we get our light here, then we set our vertices, and the only thing is changed is that we pass the maximum coordinates as the last argument, and that's pretty much how it is done for all of the other ones as well. You can see this is basically the same thing except that we are using side def upper here, and this is also the same thing except that we are using side def lower, and that's pretty much all we need to do. So if I go ahead and run make right now, what you should be able to see is that now we get the same texture, tiling and stuff, but the only difference is that now we are actually not having any modifications done to our basically we are not binding a texture for every draw call. And you'll see in the next video that we'll be able to optimize this even further by removing the multiple draw calls and merging them into a single one. But before that, I need to show you a bit of a fix to a small problem. So in what.c there is a small problem in the what read patch function. We must make sure that we initially zero out all of the fields of the patch, because if we don't do that, then if we return early, the patch may contain invalid data if it's uninitialized. So we just make sure that when you're reading the patch, you first of all set all of the patch values to 0, so that will make sure that no undefined behavior occurs. So let's close that up, and yeah, this all is some pretty basic stuff, but well, one way we can change this is that inside of the engine render function, so engine render, if I go here, you can see we are setting the wall texture and the flat texture and everything. Well, we can just set it inside of our main function, so initialization function I mean. So we are going to just set this here, and now what you should be able to see is that it still works and we don't need to actually bind it every frame, because well, it's the same texture, so no need to actually bind it again and again. But you can see that it basically works, and it seems to work quite well. And yeah, you can see that this is pretty awesome. We can see everything is working, and it's looking quite nice. So yeah guys, this is going to be pretty much it for this video, and I'll see you in the next one, in which you're going to look into some more optimizations. I want to have all of the optimizations and everything we need to implement for the render done before we move on to skies and stuff. So stay tuned for that. Make sure to like and subscribe as well, and share this video with other people, and I'll see you in the next one.